Okay, students, it's really happy to uh, see here in this wonderful morning. And today I have come with a problem solving linear homogeneous recurrence relations. Now, what is given here is the question. Tn equals 3, Tn minus 1 plus 4, Tn minus 2. Look at that. This is what a recurrence relation, because this term is based on the previous two terms multiplied by some coefficients, and also some initial conditions are given. Tn equals 0 if n equals 0, Tn equals 5 if n equals 1. That's what the initial condition given to us. So that's all. What we have to find, the solution of the recurrence relation we have to find out. Already I was discussing about the solution of a recurrence relation. Am I correct? A solution of a recurrence relation is nothing but the terms or the sequence which satisfy these recurrence relations. The sequence an which satisfy this recurrence relation is called the solution of this particular recurrence relation. Okay, we'll find out a an formula, and that should satisfy this particular condition with this initial condition given to us. Now let us solve them. Now, given equation is Tn equals 3 Tn plus 4 Tn minus 2. Here actually 3 Tn minus 1 should come there. Some small mistakes, that's all. Now you bring this side. When you bring this side, you will have Tn. This will come here, minus 3 Tn minus 1 minus 4 Tn minus 2 equals 0. Yes, it is true. Am I correct? If you are bringing these two terms to this side, you will get this. Okay, so right side becomes 0. I am taking this as equation number 1 because in the future we may be using this equation. That's why I have taken this equation as 1. Now, we know from the differential equation solving of differential equation, this characteristic equation corresponds to this, or if this is the differential equation with the variable n minus 1 n minus 2, then the corresponding characteristic equation is this characteristic equation. What is this? Some problems coming. Change the color scheme of the windows, keep the current color scheme, keep the current color scheme, and don't show this message again. Now, so the characteristic equation 1 is r squared minus 3r minus 4 equals 0. Okay, right. So once we find out the characteristic equation, we can get the characteristic roots. How is that? By solving this. We know that the solving of quadratic equation like this, x squared minus 3x minus 4 is 0. Am I correct? Like that, we are solving this equation. That's what we have to understand. R squared minus 3r minus 4 equals 0. If you factorize, you will get this. R plus 1 into R minus 4 equals 0. R plus 1 plus R minus 4 equals 0. This is a factorization of this characteristic equation. Now let us find the root of this. If these two are characteristic equation, then this must be equal to 0, and this characteristics are, this factor must be equal to 0. Individually they must be 0, then only the product must be 0. So we have r plus 1 equals 0 implies r1 equals minus 1, and r minus 4 equals 0 gives us r2 equals 4. So the two roots are r1 minus 1, r2 equals 4. So we know from the differential equations, if the two roots are existing, then the general form of the solution is Tn equals C1 into R1 to the power n plus C2 into R to the power n, where R1, R2 are two roots. Okay, right, so here R1 is minus 1, R2 is 4. So substituting in this general equational format, we'll get Tn equals C1 minus 1 to the power n, because R1 is minus 1 plus R2 is 4, therefore C2 into 4 to the power n. This I am taking as equation number 2, because this equation may be useful in the future. Right. Now, you must note that without finding C1, C2, the problem cannot be solved. I mean, we cannot find out what is Tn. I mean, we cannot find out the solution of this particular regressions relation. So our aim is towards to find out what is C1, what is C2, how is it possible. So in your differential study, you must know that the initial conditions are very much useful in solving the finding out of the constant involving the solution. So we are applying the first initial condition here. The first initial condition is that n is equal to 0 implies Tn equals 0, n equals 1 implies Tn equals 5. So let us use that here. If n equals 0, Tn equals 0. So substitute in this solution here. If n is equal to 0, then you will get C1 into minus 1 to the power 0 plus C2 into 4 to the power 0. You will get 0 here, so you will get C1 plus C2 equals 0. That's what when we substitute this initial condition in the solution, equation number 2, we'll get equation number 3. Right. Now another condition also given here. What is another condition? If n equals 1, Tn equals 5. n equals 1, Tn equals 5. So take that one in this particular solution. If n equals 1, put n is equal to 1, you'll get T1 is 5. Am I correct? So 5 equals C1 minus 1 to the power 1 plus C2 4 to the power 1, and you will get this equation number 4. You will get if n is equal to 1, Tn is equal to 5. You substitute that, you will get equation number 4. Right? Okay. Now how can we find out C1, C2? Look at the two equations 3 and 4. If you solve them, you can get C1, C2. Am I correct? So solve them. You add both of them, you will get C2 is equal to 1. Am I correct? If we add C2 plus 4C2, 5C2 equals 5. Therefore, C2 is equal to 1. C2 is equal to 1. Substitute this C2 is equal to 1 in the third equation or fourth equation. You will get C1 equals minus 1. C1 equals minus 1. So substituting these values of C1 and C2 in equation number 2, that is this general solution of the differential equation given to us, we will get Tn equals minus 1 to the power n plus 1 into 4 to the power n, because the value of C1 is minus 1, the value of C2 is 1. So we are substituting that 1, we'll get this one. So if you simplify them, what we are getting is that Tn equals 4 power n plus minus 1 to the power n. Tn equals 4 power n plus minus 1 to the power n. Okay, so this is the terms definitely will solve the given recurrence relation. Tn equals 3Tn minus 1 plus 4Tn minus 2, and thus this is the sequence formula which satisfies the given recurrence relation, this one. So that's we can solve any given homogeneous linear relations. Okay, so thank you very much. I will come with another problem in the next class. Thank you.